In this example, the goal of this program is to demonstrate a simple time schedule control using the WeekSchedule function block. First, let's look at the variables used in this program. We start with the function block instance. FB WeekSchedule. This is the main scheduling block responsible for handling the weekly time events. Next, we have some output and diagnostic variables. XOutput bool, XTrigger bool, USI event usant. In this example, we are using two events. Event 0 turn on, event 1 turn off. Next, we have XSimulate bool, XSimTrigger bool. Finally, we have iCounter int. The first part of the logic is a simple counter. The counter increments every PLC cycle. iCounter equals iCounter plus 1. When a counter reaches 100, it resets back to 0. If iCounter greater than or equal to 100, then iCounter equals 0. END_IF. This counter is useful for creating periodic events during simulation. Next, we call the WeekSchedule function block. The scheduler is enabled using I_xen equals true. Then we configure the number of events. I_send our events equals 2. This means the scheduler manages 2 events. The parameter I_PTRE2_event equals 0 normally points to an EEPROM memory address where scheduled data is stored. In this example, we are not using EEPROM, so it is set to 0. I_reset event equals false. This means the scheduler will not reset the current event state. The outputs of the function block are connected to our variables. Q_XTrigger event XTrigger. Q_SL last event USI event. Whenever a scheduled event occurs, XTrigger becomes true for one cycle, and the event number is stored in USI event. Now we process the scheduler output. When a trigger occurs, we check which event happened. If the event number is 0, the output turns on. XOutput equals true. If the event number is 1, the output turns off. XOutput equals false. This creates a simple on-off schedule behavior. Because the real scheduler may require configuration or EEPROM data, we also implemented a simulation mode. When XSimulate is true, the program generates artificial events. The counter we created earlier is used to trigger the simulation. Each time the counter resets to 0, the variable XSimTrigger toggles. This means the program alternates between 2 states. When a simulation trigger is true, the output turns on. When it is false, the output turns off. This allows us to visualize the schedule behavior during testing without configuring real-time events. To summarize how the entire program works, the PLC continuously runs the counter to indicate the program is active. The WeekSchedule function block monitors the time schedule and generates event triggers. When an event occurs, the program checks which event number was triggered. Depending on the event number, the output is turned on or OFF. If simulation mode is enabled, the program generates artificial on and off signals using the counter. This allows the developer to verify that the scheduling logic and output behavior are working correctly before deploying the system with real schedule data.